This is some Algebra 2, and these questions are about finding the equation of a parabola using the distance formula. And I'll zoom in a little bit for those of you without the eyes to see when it was that small. I can see it when it's that small with my glasses. So with my glasses, I have good eyes. But okay, let me put this. I'm going to write this or draw it so you can see the situation. Here's my coordinate plane. My directrix is at y equals 2. So it's a line at y equals 2. It goes on forever. It's somewhere, any point on that line is on the directrix. So that's the direct, I'll just put little d for directrix. Then here's my focus, 0, -2. And remember, the focus and the directrix, the focus and the vertex are on the same, if it's a vertical parabola going up or down, they're on the same vertical line. So since the focus is here, that means the vertex is here. And the focus is inside the parabola. So this parabola looks a lot like that. Maybe not exactly because I'm a bad artist and it should be symmetric. But anyway, so that's it. So I have to take some, I'm going to put some point on the directrix, and this is called, I don't know, the directrix point. I'm going to call it x. It's got some x value, and then it's always got the y value of 2. And then down here, I'm going to pick a point on the parabola that has the same x point. So this is some point on the parabola with the same x, and I don't know what the y is of that point. So that's this. Maybe I'll do that one in a different color. How about that? There's the point on the parabola. It's pxy. And I want to pick it so it's exactly the distance between it and the point I'm picking on the directrix is perpendicular to the directrix. In other words, the x values again are the same. So now I just have to take the distance from this point on the parabola to the point directly above it on the directrix, where the x values are the same, is the same as the distance from this point on the parabola to the focus. So I just have to use the distance formula. Remember the distance formula. The distance formula is equal square root x2 minus x1. They're just x values of the 2 points. Squared minus y2 minus y1, the y values. And it's important to keep them straight. Mark which point you're calling 1 and which point you're calling 2, so you don't flip-flop this because you'll get wrong answers. So to find the distance between this point on the directrix and this point on the parabola, I'm going to call this one 2 because I want the y to be in front, and this one 1. And I'm going to do the distance formula. I get the square root. Well, this x2 is x, x1 is x, it's the same x value. I purposely picked it like that, squared, plus y minus 2. Y minus 2. The y value for point 2 is y. The y value for point 1 that I picked on the directrix is 2. And I'm trying to, oh, I thought I needed more room, but I guess I don't. Equals. Now I'm going to do the distance between point P and the focus. And I will do, I'll call this 2 and this 1 in this case because I want this x and this y to be the first things, the positive ones. So I square root x2 is x minus x1, which is 0, plus y2 is just that y. Y for the second point is y. I don't know what it is. Minus -2, which is plus 2. And by the way, I forgot to put the squared. Why didn't you tell me this? And the squared. And the squared. All right, this is just 0. This is just x minus 0 squared is just x squared. So now I have y minus 2 squared equals the square root of x squared plus y plus 2 squared. And they're both square roots. So I can just square both sides. And now I have y minus 2 squared. This thing went away and I squared it. So I got rid of the square root equals x squared plus y plus 2 squared. And now I just have to square these things. I'm going to do y minus 2 times y minus 2. And this one I'm going to do y plus 2 times y plus 2. And so first times first is y squared. Inside, minus 2y. Outside, minus 2y is minus 4y. Last times last, negative 2 times negative 2 is positive 4. Equals x squared plus, first times first, y times y is y squared. Inside 2y, outside 2y plus 4y. Last times last, 2 times 2 is 4. And let me see what can y squared and y squared are the same on both sides. If I subtracted y squared from both sides, they'd both be gone. 4 and 4 cancel. If I subtract 4 from both sides, they'd both be gone. So I got negative 4y equals x squared. Oops, I forgot to subtract that 4y from both sides. Negative 4y minus 4y is negative 8y equals x squared. And now I just divide by negative 8, y equals, I can just put negative 1/8 x squared. I can also write that as negative x squared over 8, however I want to do it. But there's how to do it. You find a point on the parabola, a point on the directrix. Make sure the point on the directrix is directly above it. Find their distances using the distance formula. Find the distance between your point on the parabola and the focus, and then set them equal to each other and solve it. And you get this beautiful equation for the parabola, negative x. Y equals negative x squared over 8. All right, I have another one. I'm going to do number 6. In the book, the even ones do not show answers in the book, but the odd ones do. So this one wouldn't have an answer in the book, so I'm going to do this one. And there may be some other ones that the course calls for, but you'll be on your own on those. This is going to be y equals 7. I'll call it up here. So again, I'm going to take some point on this directrix that is some x value and 7. And then I'm going to take the focus, which is 0 minus 7. Down here is the focus, is 0 minus 7. And remember, the vertex is on the same line as the focus. And right there, so this parabola looks like that, something like that. I don't think I'm exactly, well, I want to be a little more even. It's got to be even on both sides. And I'm not an artist, so I always have trouble with this. So now I'm going to pick a point. Well, this is going to be hard, so maybe I better move this point over here. I'll pretend that's x7. So I'm going to take a point P. This point P has some x and some y. And I will take the distances. This is supposed to be directly above it, and it's perpendicular to the directrix. So I'm going to call, again, this point 1, this point 2, and I'll write it's the distance between point P and that point on the directrix, x minus x squared, which is 0. So I'm not even going to write it, x minus x, and then the whole thing squared is 0 squared, plus y minus 7 squared. So I'm just going to put that, y minus 7 squared equals, and now I'll call this point 1, and I'll do between P and the focus, I'll do x2 is x, x1 is 0, so it's x minus 0, the whole thing squared, which is just x squared, plus y minus negative 7, which is y plus 7 squared. And now I can just square, I think sometimes I might misspeak and say square root both sides. I want to square both sides to get rid of those square roots. I get y minus 7 squared equals x squared plus y plus 7 squared. Now on this one, if you want to write y minus 7 times y minus 7 and FOIL it, you can do that. I'm going to just do it because I know what it is. It's y squared minus 14y plus 49 equals x squared plus y squared plus 14y plus 49. And so the 49's cancel out, the y squares cancel out. I subtract 14y from both sides. I get negative 28y equals x squared. Remember, all of this has canceled out. Canceled out. And then I just divide both sides by negative 28. Y equals x squared over negative 28. I can also write that as negative 1 over 28 times x squared. Either way. So that's a couple of those, using the distance formula and using a point on the parabola, a point on the directrix that's directly above or directly below it, and the focus. Find the distance between that point and the point on the directrix, set it equal to the distance between that point and the focus, and then solve it for y. Get it in the form of y equals, and you'll have the formula for the parabola. In this case, it's y equals negative 1 over 28 x squared, and in this case, it's y equals negative 1/8 x squared. Once you do it a few times, it's not that hard.